7.3, we're carrying over a lot of the same algebra problem solving concepts that we talked about in 7.2, but this time we're going to be using multiplication, division, and the inverse property to solve these equations. So if we just start right down here in example 1, in class we wrote down a couple notes. We wrote down what we had in 7.2. The goal is to get the variable by itself. And then we wrote the rule is whatever you do to one side, you have to do to the other. Over here on the side, we also wrote down some notes about how we get rid of different operations. Our goal is to get the variable by itself, so when we see something we need to get rid of, how do we do that? To get rid of addition, we will use subtraction. To get rid of subtraction, we will use addition. Multiplication, we'll use division. Division, we'll use multiplication. And then probably the one that's going to be the most challenging is to get rid of a fraction. We're going to use, kind of running out of room over here, we're going to use the reciprocal. When we use the reciprocal, we flip the fraction and then multiply. And we will look at an example like that in just 1 second. Alright, in A, it says we need to solve w divided by 4 equals 12. So the first step in algebra is always to rewrite. And again, we might be able to look at this and know right away that w equals 48. However, that doesn't mean that writing down w equals 48 is going to get me full credit for this. I need to solve this written out in steps for algebra. So the goal is to get the variable by itself. So here's my variable right here, the w, and I want that to be by itself on the left side of the equal sign, which means that I need to get rid of a divided by 4. To get rid of division, I need to use multiplication. So I will write multiply, and then I always use the same number. So if I want to get rid of a divided by 4, I will multiply by 4. My rule is whatever I do to one side, I have to do to the other. So multiply 4, multiply by 4. The times 4 and the divided by 4 cancel out. And all that I'm left with, I'll make sure my equal signs line up here. All that I'm left with on the left side is w. 12 times 4 is 48. B is where it gets a little more complicated. Rewrite, so I have 2/7 x, which is really 2/7 times x, equals 6. My variable is over here. The goal is to get the variable by itself, so I want x to be alone. I need to get rid of this fraction, 2/7. So looking over here at the list, to get rid of a fraction, I'm going to use its reciprocal. We used reciprocals before when we were working with dividing by fractions. To change the division problem into multiplication, the students would find the reciprocal. The reciprocal is when we flip the fraction over. So instead of 2/7, we do 7 divided by 2, 7/2, and then we multiply. What that does is turn this whole thing into one whole. 7 times 2 is 14, 2 times 7 is 14, 14 over 14 is 1, and in that way I can cancel these out. Because even though this will end up being 1 times x, 1 times x is the same as x, so it still lets me accomplish my goal of getting the variable by itself. Whatever I do to one side, I have to do to the other. I cancel these ones out, and I'm putting my equal sign down right under there, x equals, And we know how to solve multiplying fractions from, I believe it was chapter 2. 6 times 7 is 42, over 1 times 2 is 2. 42 divided by 2 is 21. There's also the shortcut of looking for canceling in this problem. Had I gone up here and said, okay, I can cancel the 6 and the 2, I can divide both of them by 2. 6 divided by 2 is 3, 2 divided by 2 is 1. Then I would have skipped this fraction here and gone straight to 3 times 7 is 21 over 1 times 1 is 1. 21 over 21 is just 21. In example 2, we're following all the same steps, even though the notes aren't over here, and we're going to solve 5b equals 65. Again, I cannot stress how important it is. It does not matter if we can look at this and say, okay, I know b equals something. That's not what we're being graded on. That's just knowing how to multiply. And multiplication is not what this is testing us on. This is testing us on, can I write out all of my steps of algebra and come down to the final answer? We're practicing those steps so that later on in 6th grade and also in older grades, we know how to do all of those steps. So you're going to get graded not on having b equals and the correct answer, but on having all of those algebra steps. Plus, those algebra steps help prevent us from a lot of silly mistakes. So here's my variable. I want to get it by itself. There's a 5 touching it, which means it's a times 5. To get rid of a times 5, I'm going to do divided by 5. I'm going to do my bar for division just because it's a little neater way to write this. The times 5 and the divided by 5 cancel out, and I'm left with b on this side. I want to make sure my equal signs line up correctly. And then I need to figure out what 65 divided by 5 is. This is where students can write out to the side and try to solve the answer. 5 goes into 6 once. 1 times 5 is 5. Subtract, get 1. Bring down the 5. 5 goes into 15 3 times. So our answer is 13. Again, this is because the direction word is solve. b equals 13. We're going to see in other places, like at the bottom of this page, where our direction word is solve, but then I also have the direction word check. So I'm going to show you how I would check example 2 if it said that in my directions, but obviously checking to make sure we get the right answer would be a good practice to do on every problem. So again, this right here is the direction solve. If my direction said to check, then I would take the given value, this goes back to 7.1, I would take the given value, 13, and test to see if it's a solution of this equation right here. So 5b equals 65. Rewrite. I'm going to plug 13 in where b is and say, does that equal 65? I would work out to the side. Right here, let's see. 13 times 5. I'm not just going to assume it does because I did division over here. I could have made a mistake in that division. So I'm going to write out my multiplication. 5 times 3 is 15. 5 times 1 is 5 plus 1 is 6. Yes, that is 65. So we would say yes. Sometimes we had been saying true. And as long as I get yes over here when I check, so this is the check part, as long as I get yes over here, then I know that I solved it correctly. If I got no over here, if for some reason I ended up with 60 equals 65, and I was going to cross that out and say no, they're not equal, that means I did something wrong either over here in getting b equals 13, or I also could have made a silly mistake in my check. But regardless, if you get no, you need to start over because there's a mistake somewhere in all of that work. Alright, example 3 is a real-life application, which always means that's the type of problem we're going to see show up on a test. So real-life application problems start to combine the skill that they're practicing, that we're practicing, with something else. So the other thing that this is giving us is geometry. The area of the parallelogram-shaped courtyard is 2,730 square feet. What is the length of the sidewalk? So to solve a problem like this correctly, first of all, we need to know that the area of a parallelogram is base times height. We need to know on a parallelogram that the base and the height are perpendicular. So that's really the two that we're looking at. It doesn't matter which one I call base or which one I call height. So I'll just go ahead and say that this is the base, and I'll use the variable b. The length of the sidewalk then would be h, because I'm calling it the height. I could also use L, it's not going to matter. So to find area equals, I'll write this out, base times height. It told me what the area was. The area was 2,730. I'm going to make sure my equal sign stays lined up. My base over here, I chose to make that the base is 65, times my height is h. I could again have called it L for length, it doesn't matter. Now I want to solve. So here's my variable, I want to get it by itself. So instead of times 65, I'm going to divide each side by 65. The times 65 and the divided by 65 cancel out. Line my equal signs up. I'm left with h on this side, and then I have to do this division. I'm going to come down here so I have some space. 2,730 divided by 65. There's another video tutorial that shows exactly how to do a division like this, but basically we make kind of a cheat sheet. So one group of 65 is 65. If I add 65 again, two groups of 65 is 130. If I add 65 again, three groups is 195. If I add 65 again, four groups is 260, and you just want to make sure we're not making any silly mistakes in there, because that can really mess us up. Okay, so now that I kind of have this cheat sheet of a quick multiplication facts of 65, makes this division problem easier. 65 does not go into 2, it does not go into 27, so I'm looking at how many times does it go into 273. I look down my cheat sheet. 260 is as close as I'm going to get to 273 without going over, so that means it goes in 4 times, which is 260. I subtract to get 13, bring down my 0. It goes into 132 times. Subtract to get 0. My answer then is 42. 42 for my height. I want to check it to make sure I get it correct, so I'll go back up, rewrite 2,730 equals 65 times h. 2,730, equals 65 times 42. I'm going to write out my work. 65 times 42. And I get 2,730 does equal 2,730. So yes, I have the correct answer. So I'll box in my final answer. 42 equals h. So what is the length of the sidewalk? The sidewalk is 42 feet long. As always, if you have any other questions about 7.3, please feel free to email me. And if you are a student who has watched this video for extra credit, the secret code word is rainbow.